In this lesson and the ones that follow, we will look at dimensional analysis. This is where we convert values among different units, and we use this technique, dimensional analysis, to solve problems. You may have heard dimensional analysis called different things, such as unit analysis or factor label method, but these are all the same thing. We're analyzing the units or the dimension that's associated with a number. You've already used dimensional analysis in your everyday life, you just didn't call it that. For example, if somebody asks you how many inches in 1 foot, you know it's 12 inches equals 1 foot. If they said how many inches in 2 feet, you say, well, it's 24 inches. And that's dimensional analysis. You've looked at the units, you've used a relationship to connect the two values, and then you solve the problem. But a lot of times that math is easy enough you can do in your head and you don't have to write it out. We're going to go through the process of writing it out because we're going to very quickly get into problems where we can't do the math in our heads. Asking about how many ounces in 1 pound, we know that relationship. So when we're doing this process, what we want to look at first is when we read the problem, we want to look at our starting units. So where are we starting from? Then we look at what relationship or conversion factors do we know between sets of units that is going to help us get from where we're starting to what unit we're looking for. So what is given and what do we know? Those are the two questions we ask ourselves. So for example, if we have 1 foot is 12 inches, or we can write it as 12 inches over 1 foot, that's an example of a relationship. And whether foot is on top or bottom depends on the setup of the problem. Another thing important to remember is if our answer is a simple unit, so kilograms, meters, inches, any of those things, our setup will also start with a simple unit. So we're not going to start the problem with a relationship if we want to end up with a simple unit at the end. And the last question we ask is, does the answer make sense? If I'm trying to find the mass of a single atom of carbon, and I get that it weighs 47 kilograms, I'm going to see that that doesn't really make sense. A single atom doesn't have a mass of 47 kilograms. Likewise, a distance, if it's a very long distance, I'm not going to see it's going to be 3 millimeters. So thinking through the reasonableness of an answer is also important. Let's work through an example together. How many inches in 2.6 feet? The first thing we need to decide is what are our starting units. So we're going to start with feet. That's the value that's given. It's in feet. And then what units do we want for our answer? Inches. So we're going from feet to inches. And we have to figure out what relationship or relationships do we know that's going to help us connect feet and inches. And we know that 1 foot equals 12 inches. Okay. Now we can look at how we set up the problem. We're going to start with our given value of 2.6 feet. Notice that I have a number and a unit there. Every number that we write down should have a unit associated with it. We're going to use these units to help us set up problems correctly. That's where the dimensional analysis comes in. Next, we'll put up a fraction for our relationship, and whether you use parentheses or times symbols, it doesn't matter. And then I need to look and figure out what's going to go in that parentheses, in that fraction. And I see that feet is in the numerator, which means I want to get rid of feet and get to inches. So therefore, feet must go in the denominator of the next step, so they can cancel each other out. And then I go to my relationships and I see, well, 1 foot equals 12 inches, so I know there's a connection between feet and inches. The other thing to notice is that I put the units in first. I'm much more worried right now about getting the units set up correctly and then putting my numbers in, because if the units are wrong, there's no way my answer can be correct. Now I know I've got inches over feet. Now I can go back and put in my numbers, which is the relationship between inches and feet. It's 12 inches is 1 foot. So there's an equality there. Anytime I have a numerator and denominator, there must be some equivalency there. So 1 foot equals 12 inches. Now I'm going to cancel out units. So I cancel out feet because I have one in the numerator, one in the denominator. They cancel out. And what I'm left with is inches for my unit. And when I do the math, I get 31.2 inches. However, We can't just leave it as 31.2 inches. We have to look at the correct number of sig figs. When I look at my original number, I have 2.6 has 2 sig figs. If I look at 1 foot equals 12 inches, those are exact numbers because that's a definition, so we don't look at sig figs for that. So the only number we're dealing with is 2.6, 2 sig figs there, so our answer must also have 2 sig figs. So we round that to 31 inches. Let's look at another example, but this time converting between units with different metric prefixes. First, we want to identify our starting units, which we have liters because the number in the problem is 4.3 liters. For our answer, we want it to be in milliliters. For the relationship, in this case, we're going to look at the meaning of the metric prefix. So milli means 10 to the minus third. Therefore, 1 milliliter equals 10 to the minus third liters. Remember our expression. Put the 1 with the prefix and put the meaning of that prefix with the base unit. Remember, the base unit is our naked number, liters, grams, meters. Now we can set up the problem. We have 4.3 liters. Set up our fraction. We know that liters needs to go on the bottom because we need to cancel that out. And the relationship I know is between liters and milliliters, so I will put milliliters in the numerator. Now I can go back and put in the numbers, the numerical relationship there. And so I put the 1 with the prefix, so with the milliliters, and the meaning of milli with the base, 10 to the minus 3. Liters cancels with liters, and I'm left with units of milliliters. When I do the math, I get 4,300 milliliters. Now we need to go back and look at significant figures. With 4,300, it's ambiguous as to whether it has 2 or 4 significant figures. So we're going to write that in scientific notation to avoid any ambiguity. I see that I only have one number, the 4.3, which has 2 sig figs. The meaning of a prefix is a definition. It's an exact number, so I don't look at that for determining the number of sig figs for the answer. Therefore, I need 2 sig figs in my answer, so I have 4.3 times 10 to the third milliliters.